But I'd like to just wrap up, this theme of supplying U.S. solar. We've heard a lot from the technology vendors throughout the day, and I'd love to just get a gut check on all of that and hear from the people that are actually buying the technology, the people that are taking that technology, and looking at all the different requirements from the financiers as well as the developers. Looking at what's available as far as the technology and really integrating that and doing the hard work of making power from these disparate pieces of hardware. So I'll have each of these gentlemen introduce themselves quickly. We're probably going to get cut off a little bit. Just so for those of you that are planning, we're probably going to end the conference about 15 minutes late at 3:45. Just to start off with, actually let's start with making introductions and just a quick question in the form of out of the technologies that have been presented on the module side, the inverter side, and BOS throughout this afternoon. What kind of things have you seen what's the one thing that you've seen that's most exciting to you? So Bill, do you want to start off?
Sure, I'll introduce myself. Thanks for sticking around, I appreciate it. I have been in solar for a long time, and my old boss, Len May, some of you know, once told me that EPC was the necessary evil that stood between sales and the customer. So that's my perspective on this topic, and actually I think he's right. There's a lot of waste in that transaction. I work for Lend-Lease. I'm VP of the Energy EPC group. Lend-Lease is a global property and infrastructure company. So we're a very big organization, and we're involved in energy management on our own assets, which are about 60,000 military housing units and lodging units, and more recently in the last couple of years, we've become an EPC. We come at this from an interesting perspective to answer your question. We have this heritage of 100 years of construction, and we build things like the Sydney Opera House and the Twin Towers at Kuala Lumpur. So we know how to build things. And that informs us, but at the same time, when you look at construction, we believe that there's a tremendous amount of waste involved, non-value added activity. And so our perspective today is what we can really control is the labor and the effort to put the system in. And I think that there's a tremendous amount of opportunity there. So we look at systems and equipment that allow us to more effectively deal with the total cost of installation. So more novel racking systems, improved canopy systems, which we have developed ourselves, things of that nature.
Sure, and we'll dive into those a little bit later.
Great.
In the meantime, Stephen, I know you haven't built anything as impressive as the Sydney Opera House, but go ahead and introduce yourself.
No, that's okay. I'm Stephen Smith, CEO of Solvita Energy Group. We are a technical consultancy firm based in Berkeley, California. We are a B2B consultancy company. We help clients make intelligent decisions about the technical choices of their applications and products, sort of how to put things together in a way that is most efficient and conducive to what their desires and constraints are for their projects. We have a second company, Solvita Design and Engineering. We founded that out of Solvita Energy Group earlier this year. We've designed about 45 megawatts of mostly ground mount utility scale projects, mostly in the West, but we are starting to see some stuff in new markets. And I'd say that in general, I think the move towards more distributed architecture, less hardware, stuff like the BLA harness, stuff like the string inverters is most exciting to me because I think in decentralizing systems, it allows solar projects, which are typically on very large areas, to be constructed more in a synchronized fashion. We call it sort of a horizontal work plane. Somebody says to me, how fast can you build a 10 megawatt project, or could somebody build a 10 megawatt project? And I say, well, how big is your crew, and how well are they coordinated? Things like central inverters and more centralized technologies make that type of construction more difficult. But when you can decentralize things, when you can take it out of specialist hands, such as going from central inverter to string inverters, or going from combiner boxes into harness assemblies, you can really jack up the efficiency and the acceleration of your project. So I'd say that's what I was most excited about today.
Great. Rob?
Thank you. Robert Wanless. I'm with a company called M&W Group. We are a Stuttgart-based, privately held company. Does about $4 billion in revenue a year. Most of our activity in the solar space from 2000 to 2010 was all on the fab side. So a lot of the high-tech fabs, module fabs, we were fortunate to do the design, build, construction of those projects. We acquired a solar EPC company about 1.5 years ago called Gerlischer Solar. They are a true EPC, turnkey EPC provider based up in the Northeast. Most of their activity had been, New Jersey northwards. More recently, we're doing a lot of utility scale in the desert Southwest. What excites me the most, I think, is a lot of our pre-sales pipeline right now is looking at late 2015 or Q2 2015 through 2016 through to the ITC cliff. And the 1500 volt solutions, I think, is what intrigues me the most, the cost savings that we see there. We obviously don't have a lot of people in that field right now, but I think as we graduate and we get more systems deployed at a 1500 volt level, you'll see those benefits. Not just on the hardware side, but on the production side, and we haven't realized that as of yet. So.
Fantastic. Nick?
Hi there, I'm Nick DeVries, VP of Plant Ops and Engineering at Phoenix Solar, responsible for the design and performance of our power plants here in North America. Phoenix Solar is founded in 1999, so 15-year veteran of the solar industry, starting in Germany, expanding throughout Europe, Southeast Asia, and the United States. 15 years has actually got us in position to have plants in O&M for 10 years, or now long, 2002, 13 years. And actually perform a inverter wholesale replacement out at around, it was year 8, not 10 to 12. But this was older equipment. Right? And so that's our lineage and heritage of the company, capabilities. Here in the United States, we focus on large commercial and medium-sized utility scale projects. Most recently, one of my most proud to build was the largest power plant east of the Mississippi. So east 38 megawatts in good Southern Company territory, feeding Georgia Power and Georgia Transmission. And
what are you excited about? What technology?
What am I excited about? I'm a PV guy. So much of this is really interesting. I actually liked a lot of the things on the commercial side. But focusing on 2015 and 2016, I'm actually able to be making engineering choices really for plants in 2016. Maybe to mix it up a little bit and not follow suit, is getting rid of some of the things we don't need. We don't need inverter metal skids that don't make power. And getting rid of some of the things that cost money, don't make power, and so I'll go with some of Dean's slides with the new larger central inverters that do away with some of this integration things that we've dealt with.
Well, great, and I think that brings up Bill's point from earlier. That you see a lot of waste within the how EPC is being done right here, and I just saw a lot of developers perk up and say, "Oh, we can tell these guys to lower their prices even more next year, right?" But
maybe the
seriously,
most unpopular person on this.
You might have lost a few clients.
yeah, you might
Set a new bar.
No, but I'm curious, where do you see that waste? Where do you Nick is talking about larger central inverters that don't necessarily need a skid. Where are some other places where you think we can lower the cost of installing solar?
Yeah, I think there's a lot of waste and confusion at a typical job site, especially when you talk 1 to 10 megawatts or even smaller, where there's a tremendous amount of non-value-added activity where people are moving things around, they're staging things, they're fixing problems, they're not sure what to do. I ran a factory for 10 years for BP Solar, and the thought to have people come into the factory and sort of figure out what they were supposed to do each day wouldn't make a lot of sense. But you see that in construction sites frequently. So it's really in motions, in making mistakes, And another one is not having the right material at the right time or disruptions in the workflow. We just did 90 Walgreens, and at the end of that, we were doing the systems in less than 3 days. They were 50 kilowatt systems, and in my view, that was at least twice as long as it should take.
So what are some of the solutions to that then?
Yeah,
some-
sorry, let you answer.
Oh, no, just
Ask
some
the question.
concrete paths in
Yeah.
order to reduce those costs.
Yeah, so I think we use a value stream mapping process, and we do a plan for success with our subcontractors. We take the approach that the subcontractors are part of the team. They're not on the other side of the table, they're part of our team. So you have to really plan the work and then work the plan. You have to map out what's going to happen from day one, from moment one. Where are you going to put the materials? What is each individual on the job going to do? So when we have electrical contractors and mechanical contractors on the site, we don't let them decide what they're going to do. We tell them, you're an A, you're a B, you're a C. So it's really being very thoughtful and very prescriptive about what happens. And there's at least 50% of the labor that's wasted on a site. And technically, from a lean perspective, it might be 80. So that's the opportunity. You're not going to get it all.
Sure.
So it's planning the work is what's really important.
Sure. Nick and Robert, both of you have been in the EPC business. Your companies have been in the EPC for solar for a while. Do you guys still see these sorts of same logistical or process issues that you need to work through? And how are you working to solve them?
Okay. No, this is a good point in how you build and operate in the field, right? It's you want to get to this lean mentality, just like a factory, where people are working on the same processes over and over again, refining them and refining them. So we still see these out there right now, and I would take it comes from the simplicity in the design, right? And you can still get further improvements by simplifying things. If we can reduce your SKUs on your BOM, if you can reduce the number of different steps, right? You can still, it's cleaner, and there's still savings to be had.
Rob, anything to add?
Yeah, I agree. I mean, not all projects dovetail into a great delivery schedule of components. We hate to handle materials more than once if we can avoid it. We're on a project right now in which the modules came early. They were part of the tariff before June. They were delivered to the site, and therefore we do have to handle that product twice. We've had situations where the site was not fully cleared when we had move on, and therefore we had to handle materials up to 3 times. All of that comes with extra costs. So ideally, you can have the best planned delivery schedule possible, but unless everything aligns, especially with the site and the laydown area, you're not always going to be able to have that benefit. So.
Sure. Yeah. Stephen, from the design perspective then, what can you do to work with, make sure that the field processes go as smoothly as possible?
Yeah, let me just comment a little bit more on, I will answer that, but also, the EPC is downstream, right? We, unfortunately, stand at the bottom of the hill. So all of the dynamics of this industry, from procurement, from policy, from incentive plans, from changes in technology, they all flow downstream to the guy standing at the bottom. I'll give you a perfect example. We're designing a project that has 4 different kinds of modules, and some 60 cells and some 72 cells and some this and some that. They're dusting off the cobwebs in the warehouse from the cash grant stuff, right? And so there's everybody scrambled to get modules and throw them in the warehouse, and then the designer says, okay, well, you've got these Canadian Solar 60 cells, and you've got these JA 72 cells, and you've got this tier 2, and it's like that's a very difficult thing from a design perspective to be efficient with. Also, technology is changing so quickly. I mentioned the string inverters and how we're seeing a lot more string inverter installations on these larger projects. Well, string inverter is not typically meant to be a ground mount PV utility scale inverter. It's meant to be a all things to all people inverter. So I was out at a project that we designed, and we had the inverters up on this little rack, and we're bringing conduits out of the ground, and then we've got like 4 conduits, each with just a couple wires, because it's just a couple strings, and then those conduits have to be mated into this underside of this inverter, where basically I have my 3-year-old in there with his fingers to work on the screws. So when I looked
OSHA
at
loved that one.
yeah. But when I looked at that, I was like, I said to the contractor, this is a rooftop product, and then we're adapting it to the ground mount system. And so you have to sort of roll with the punches from a design perspective because things are changing so rapidly. And nothing is ever really consistent and not in an evolutionary phase. So that makes it very difficult. I think to that extent, and because of that, everything that these guys are talking about reducing labor and really making sure that you're touching things once, making sure that your material efficiency, how you get your material on site, that it's just allocated properly, all that stuff really, really, really matters.
Sure. And in that sense that you guys are downstream of everything else, right? And you're talking about how do you work with the technology and the hardware vendors to make things smoother. Curious from the opposite side, with working with the developers or whoever's going to own the project. What are some of the things that you're seeing that you wish they could maybe get their act together and help you guys out, throw you guys a bone sometimes?
We bid projects to numerous different developers, and some of the projects come with a fully baked data room, all the materials, everything required. Others come, piecemeal. What I think a lot of developers do is they really do a great job at, locking up the PPA, getting the special use, conditional use permits approvals, getting the interconnection rolling, at least if it's not a finalized agreement, they've got the, facility study or system impact study at least underway. What they tend not to do is really look within the fence at the ground conditions. We were talking earlier, and I think the biggest risk that we always face on these projects in the pre-sale stage is soils risk. We've nailed the DCAC, all the way up to the medium voltage collection gear. Very little risk on that piece. Where there is risk is in the soils. And most developers don't provide, a final geotech. They don't provide the hydrology study. They don't provide pull tests. And this is low-hanging fruit. I think you can go to a pull test, a pile test for 8 to 15 grand and mitigate that, de-risk that from the project. Provide a geotech report and de-risk that. And instead, they kind of throw that over the fence to the EPC, which is fine, but to cover us, we have to, increase the contingency for anything that might be in those soils. So I think, the developers, if they really looked at the site and provided a little more on the ground condition, would mitigate the risk, would provide a better price to them, and would mitigate the risk on the project, and therefore we could bid a leaner price.
Mm-hmm. But I think that's noise to them in some ways, because they're not really focused on making sure that there's a corrosion element to the geotech report, but they don't really understand that. I think, so often you're like, oh, can I get the civil survey? And somebody sends you a Google Earth map and then some plat drawing for some condo complex that now is going to be a solar farm. And you're like, what am I going to do with this? How am I supposed to, work with this? So I hear what Rob's saying. At the same time, I think what developers can do is engage with their designers and their EPCs earlier in the process. Right. How should I structure my geotech report? What should elements of my civil and boundary survey should I have or should I not have? Can you give me a template to use as a scope for me to give my geotech guy? So that way we know the inputs are right. Because when they're not right, it's difficult. And Rob brought up another great point. Designing from a geotech report and designing foundation means that you have to interpret the geotech report and you have to administer your depths and all your coefficients and stuff to code. Code is very rigorous. Code is too rigorous. Code has safety factor upon safety factor, which could add sometimes a foot or 2 feet of steel to your foundations. If you do a pull test and you are able to actually get real world data on how much power or how much energy it takes to pull a pile out of the ground, you can reduce your costs significantly and not have to design under these auspices of code. So there's a lot that I think that earlier engagement, and that's what I've been pushing my clients to say, hey, we haven't signed a contract in good faith. Let me engage with you and make sure that the geotech survey that we're getting done is what we want.
Sure. There's a lot of sympathetic laughter on that geotech, which is concerning a bit.
It's a condo complex thing. But no, I've gotten plans for golf courses. Like, oh no, we're going to do 50 megawatts here now. Like, all right.
But Bill,
I would generalize the point from the specific technical and say that the process of risk allocation between the developer and the EPC is something that sometimes leaves something to be desired. So, when you manage risks, you work to understand what the risk is, and you develop together a way to deal with that risk. Risk management is not the process of pushing the risk on another party, because that's not the way we're going to reduce cost. Lend-Lease is going to look at a risk that's pushed on us, and we're going to price that risk. That's part of the way the process works, so we can handle that if something goes wrong. So I think if the parties work together and they're honest and they have a little different relationship than across the table, you can work together to decide how you're going to manage risks together. And that leads ultimately to a much better process.
Sure, and that sounds all nice, you know, definitely we could all hold hands, sing Kumbaya together, but,
Right.
you know, at the end of the day, people don't want risk, right? And so what is, you know, what are the type of risks that you as an EPC are willing to take on, and what is some risks that you really need that developer to take on because you can't do that?
Yeah, so the question for me, we're willing to take on risks that we can take enough time, as we said, to start the process earlier, to understand those risks. So geotech, no problem. If we have control of materials, you know, if we understand the you know, deeply what's going on at the site, those kinds of construction risks, you know, we build high rises in New York City, no problem. I think the risks that bother Lend-Lease and probably a lot of EPCs are risks that are not fully revealed, or you're expected to take a risk that you don't understand. And that's difficult. I like to say that the companies that can't afford to take the risk are usually willing to do it, and the companies that can afford to take the risk know better. So.
For Phoenix Solar, on taking risks, is every deal, and every deal of size, there's trading of risks, and someone has to own it. We don't want no risk, right? People understand there are risks. The risks have to be covered and mitigated and owned, right? And there's nothing worse than one of these deals where you're bringing everyone together and everyone starts to hedge a little bit. Well, I'll do this, but I'm not responsible for that, right? And I like to just put it on the table what Phoenix Solar does when you have these other parties. We build per schedule, we hit our timelines that are contracted, and our plants perform, right? We take PR guarantees. This is what I'm paid to do. This is what I have LDs in my contracts for. That's what I do, right? Now, then there's the other aspects. To Bill's point, say, well, if it's not in my control, why am I taking this, right? And it's really not a great risk transfer. If it's really not in the counterparty's control, all right, yeah, you got rid of your risk, but did you really? Is it really covered and owned? It's probably not, right? And so long as you can, you know, beyond my Berkeley roots and wanting to sing Kumbaya, is breaking it down and who owns it, who has the expertise to own it, who has the bankroll to own it, then it's really covered, right? But you should look to your EPC to be able to manage what is in our control, right? And generally, it's schedule and performance of our design and of the plant.
Sure, I want to talk about actually one specific kind of risk, which is after you finish the project and now it has to perform, right? And you know, you guys get, you know, slogged in the general industry as, oh, the EPCs don't care, right? Because they're out after year one or they're out after year two. You know, do you guys have any response to that? You know, what sort of ownership do you have in terms of caring about how the asset performs over 20 to 30 years?
Yeah. We're a PV-only company. We're only PV. We've signed up to PR guarantees for a long time now. I'm personally a module technologist. I care about how PV operates. If you're focusing on the mission, as been talked about earlier this afternoon, you need to care about how it, you need to care about the product. And if not you, for the people to the left and right. The industry doesn't need bad names being thrown around because of XYZ quality problem or low performing power plants in the news.
Solyndra.
So,
not to name names or anything.
Right? No, so I think we need to collectively look for ourselves, but interested, you know, is the EPC really in it for the long term? We've got PR guarantees for years out, right? And if we aren't in that for period out, right, then we have these chances, right, that you don't want us to take, which is pull this, put in some other item that's cheaper, and hope that it works. It's appropriate for an EPC to be looking out years past and owning its quality down the road. It's a 25-year product.
But just on the performance guarantee, I mean, everything we bid, we back up with a 1-year performance guarantee. That's standard. many clients seek an extension of 24 months. Anything beyond that is really a function of what's that O&M program. We bid a project this last summer for a utility that has their own O&M program, won't disclose any of it to us, but want us to own a 5-year performance guarantee on the system. Well, we can't do that, right? I mean, without baking in a whole bunch of contingencies. So I think we feel comfortable going out to that stage of 24 months. But we obviously want to have a very solid understanding of who's doing the maintenance and what that looks like and that. So we do own that risk. So.
Mm-hmm. And in terms of what you've seen out there, you've brought up this idea of quality in terms of performance. What have you seen out in the field? Maybe none of these guys up on stage, right? But out in the field that you're concerned about. What factors of quality should we as an industry really care about and really seek to solve?
You're going to have to extend the session a little bit to get into that. Missing hardware, grounding systems missing, fasteners not tightened down correctly, misalignments, improper cures on concrete. Any way that a corner can be cut, if you don't have the right EPC on the job, there's a way to cut it. So I think we've all probably seen those things. Not on any of our jobs, but occasionally you see them. I wanted to, if I can, just very quickly on that last question, I think that the industry and the maturity of the EPC has to think differently about quality. We'll take those risks, we'll bring in a third party, but building quality into the plant is what's really important, and working with EPCs that know how to do that, because otherwise you're always going to be wondering about what corner was cut and what tie is going to cut through and create a ground fault down the road.
Do you need to be compensated to care about that quality?
I think if you plan the work right and you think about it, your cost will be less with higher quality. So I'm not the guy who's going to say, well, I'll give you the quality, but you got to pay more. I think it works the other way. If you really build quality in and check it as you build, then the cost should be lower.
Upfront costs.
Upfront cost should be lower, absolutely. If the work's properly defined, absolutely.
Yeah, I think that quality it's actually a critical point. And we're talking about risk and risk mitigation and who's going to get this risk and what's all that stuff. We're using here we are staring at this ITC cliff in 2 years, and we're saying, okay, well, how are we going to get better at what we're doing? Oh, we're going to raise module efficiency. We're going to reduce balance of systems costs. We're going to drive down module costs. When you're talking about risks and guarantees and performance, no EPC, no guy up here is going to say, yeah, I'm going to stand up and guarantee 100% of what this PVSys report says is going to put out. This is a huge problem. You talk to anybody in finance in this business, and they'll say, I've got a portfolio that's producing 6 or 8% more than it should be. And everybody's like, great, that's awesome. Well, that 6 or 8%, I talked with Nick about this the other day. If Nick could guarantee 5% more energy and raise, and then the investor would actually get 5% more energy on his return, Nick could raise his price slightly by 2.5%. He gets a better deal. The investor's making more money, and we're reducing that ITC gap. But right now, the way it works is, these guys are not going to sign up for a guarantee that pins performance so closely to what it actually should produce. And that's a huge problem in this industry, and something that, as we are like squeezing the lemon towards the ITC cliff, we're really going to have to figure out how to deal with.
There's no juice left in that lemon, is there?
It's a dried lemon.
There's a little bit.
But how do you solve that then? Is it just better modeling? Or?
Better modeling, measured data analysis, opening the kimono, reducing the incentives, getting everybody on the same page. This is a big grab for incentives. It's always been that way. They're going away. And if we really want to grow this industry, we have to grow up and everybody put a little bit of skin in the game. That's how you do it.
Okay, well, definitely a lot more questions from me, but I want to save some time for audience questions. So does anybody in the audience have any questions for these gentlemen? No one? Oh, right here, Tom, please. I think we have a mic coming around. For the live streamers.
All right, Tom Chaney with whatever hat I'm wearing today. Performance guarantees, what are you being asked? I mean, what's the range right now? It might depend somewhat on the project type, trackered, untrackered, all that kind of stuff, but what are you seeing out there?
Yeah. I don't see that there's too much of a difference between type of plant. It might be size of plant and the size of the risk is probably what will make it more and more stringent. We're used to seeing either capacity tests or PR guarantees, right? And PR guarantees being more of a function of, say, year-over-year performance, right? Where we're taking weather out of the equation. We're just talking about efficiency of the power plant. And capacity test is both PR and capacity tests for, call it substantial completion. And, you know, I like to say what I'm going to do and do what I say, right? And when I do my capacity test, right, and it pencils, right, we're done. You have to show that the start of the revenue stream is going to be what was modeled, right? That first quarter is pretty rough if it isn't. For how long?
We're seeing anywhere from, if it's actual weather following, anywhere from 95% to 99%.
Yeah.
And I think we're comfortable up to the 99% level for a 1-year guarantee. If it's a 2-year, maybe a percent below that. But yeah, 95 to 99, I don't know if you guys
We're
see
seeing 1 to 2 year PR ratios. We've seen 100% recently, which is not something we would do either.
Yeah.
Capacity testing, of course. It depends on who the customer is. Some customers, some larger clients are not as interested, only capacity test. They've got it from there and they have confidence in us. And smaller scale financiers may look for 10-year energy. So there's a little bit of who are you working with and what do they understand and how much do they want to allocate the risk. So those are the kind of numbers we're seeing.
Over here.
Thank you. I had a question on possible repowering of these projects. I've got a system on my roof, 260 watt panels and 2.6 kW. The inverter will go out at some point. When you guys are doing these big projects, is there thought between developers, financiers, you guys, as to repowering the system, put new panels on, new inverters?
Okay. I mean, I think that the classic repowering is on the inverters, right? And most financial models have this. It used to be inverter replacement. It's really inverter refurbishment is the better word now. And look, when we did an inverter replacement, it was a replacement. It was an older system, like Arco shell modules is old.
Now you're dating yourself.
You
Nick.
just can't, yeah, right, old school.
Old
You can't
modules.
get this stuff anymore, right? And I think that day has changed, but particularly in inverters. Inverters are now very complex, well-built capital equipment and machinery. And the way that's all handled across industries is replacement of field replaceable units, core components, having spares plans in place, and less so about just get me this new huge box and drop it in.
I'd like to add to that a little bit. You know, we've heard from some, distributed opposition companies that, repowering up with module level power electronics if you see some particular wonky module degradation in the field. Is that something you're seeing as well? Is that something that's interesting or, not quite yet?
We've looked at a lot of different technology, and there's no question that when you look at the, some of this comes from my BP days, but when you model the performance of a system and the mismatch losses and that type of thing, and even failed modules and string failure, the distributed electronics can play a significant role. So DC to DC converters, microinverters, et cetera. The issue is you trade one form of reliability and degradation with another. So in my view, in our view, the jury's out as to whether I'll say the reliability is really there to replace that kind of problem, which you can kind of go out and figure out pretty quickly if a string isn't working, versus all the electronics that might have their own issues. And unfortunately, in today's world, I think you look at Hawaii and the requirements on inverters now. If you distribute 1 million inverters across microinverters across a huge field, and they're not compatible, like is the case in Hawaii, what do you do? So there's some trade-offs there about the kind of new risk that you build into that architecture.
Sure.
Sounds like you may have been taken out to dinner by some folks at AMP or something like that.
Not recently, but I
No,
have.
not you. I was talking to MJ.
Oh, so
you know,
he's-
he's here.
He's leading the witness, right?
Yeah, exactly. Because I don't, I mean, the module companies have done a really good job increasing their warranties, creating warranties that are much more transparent, linear warranties. I'm not gonna add a DC to DC optimizer. I'm gonna go put thumb screws on my module guy and get new modules.
Right.
So we have just about a minute left, and I know Steven's got to fly back before the storm hits
into the
Bay
storm.
Area. Yeah, exactly. I have one last question, and it's because most of you guys are most of what you're doing is large commercial, utility sector stuff that's going to get hit by the ITC heavily. Just quickly, like a sentence. How are you looking at 2017?
So we're very diversified. We're not stuck on utility. The challenge for 2017 is making sure that you're ready to meet the cost challenge, and it's our own destiny to get to that point.
I'd say part of what we're really focused on is standardizing designs in such a way that really enables a super streamlined installation. I mean, people have said it before, cutting your home run wires. I mean, everything along those lines. We're really trying to, there's the best thing I can do to help the ITC cliff is to reduce risk so that financiers can say, oh, this system is actually going to produce what we said it's going to produce. We can potentially roll a lower cost of capital into that project or into our project portfolio. There's nothing more that I can do. I mean, I can do some stuff, but there's nothing more important and more influential than probably dropping the cost of capital for projects. And you do that by creating standardization, creating standard methods, and making something repeatable.
Rob?
Yeah, so we have nothing beyond 2016 in the pre-sales pipeline in the U.S. Where we've really ramped up a lot of our focus is in markets in which M&W has a strong existing presence. We got a 50-person shop in Mexico. We got a big presence in India, about 500 people there. So it's global markets outside of the U.S. I've seen numbers as much of an 80% hit in 2017 at this conference, and more conservative that we'll be back to this year's level. So, 2017 worries us, so we're trying to diversify that risk by just going global. And I think if you see where a lot of the big developers they're doing the same thing. They're not just focused here in the U.S. It's been a great ride, but they have to, get into these other markets where PV's about to take off, and it's maybe 5 years behind where we're at right now in those regions.
Sure, Nick, are you still going to be able to stay in the U.S.?
Might go back to international travel, which I used to do. Look, my company's makeup, where we are positioned around the globe is a product of this type of mechanism happening throughout the PV industry, right? We started with the German feed-in tariff and consistently saw it drawn down and diversified out to multiple other countries and continents, right, to diversify across that. Being a Berkeley native and wanting to stay working in North America, right, then it's about diversifying within the United States and looking for markets that aren't quite as pinned on the ITC. I mean, that's the holy grail of where you're going to go find that deal. But it's about being realistic with your core clients who you've built with over and over again. And they have an interest to be in the business in 2017 as well. And then finding the right deals that do it, be it moving into commercial, which we've always done, or if there's still opportunities, maybe not in the very largest utility, right, but in the smaller utility space.
Sure, and I know our utility analyst still wants a job in 2017 too. So please find a way to keep building those projects.
Until then, we support SIA and their efforts.
Sure. Thank you all for sticking around to the last session. Please give these gentlemen a round of applause. And I believe we have some closing statements for the conference as well.